So we are now going to look at some examples on Cauchy's nth root test. So we are continuing with our series on infinite series. So let's go. Here's my note. So let me write. Cauchy's nth root test. I'm just doing more examples. So let's recall what is a Cauchy test. So let summation un be a series of positive terms. By the way, we are in real analysis, so all our infinite series are of real numbers, so positive reals. So if we look at this such that limit of this general term un raised power 1 by n, that is nth root, as n tends to infinity, if this turns out to be a number L such that if L is less than 1, then we declare my series is convergent. Okay. Again, as usual, our series starts with n equal to 1 to infinity. So else, if L is greater than 1, we declare summation un is divergent. So of course, if it turns out that this limit is 1, then we don't have a clue, so the test fails. So let's look at a quick example. Example 1. Suppose we are given to test the series summation n plus 1 times x the whole power n, and this is divided by n power n plus 1. This is the kind of series that we have to test. So just to give you a feel for this, so put n equal to 1, it is the first term is 2x by just 1. Second term will be 3x square by 2 cube, plus the third term will be 4x power 3 by 3 power 4, and so on. This is your series basically. This series, if you expand, it looks like this. Anyway, so we only bothered about this. It's already given here. Sometimes this kind of an expression is given. We have to identify this expression for un. So we are already given un. So un is n plus 1 times x the whole power n divided by n power n plus 1. This is your un. So what does the Cauchy test say? We have to evaluate limit of this expression. So this expression, first we'll find it out. This turns out to be I will write it as it is. Oops. So this is the given thing. Now I'm going to raise it to power 1 by n. So it's very clear that what we get is simply this n and then gets cancelled. We just get n plus 1 times x in the numerator. In the denominator, well, it is n power n into n. This n power n with taking the nth root comes out to be just n. And what remains is that n power 1 by n. This is your un power 1 by n. So now we take limit both sides. So limit un power 1 by n as n tends to infinity is limit of this expression as n tends to infinity. So here a small bit of information. We know that only this term, which you may feel is a problem creator, but we know that n power n by 1 by n limit as n tends to infinity. We have checked out in the studies of sequences that this tends to 1. So this is a small bit of information which we are going to use. So, so what we do is we simply take this expression out as a limit, and we'll just try to take it outside. 1 plus 1 by n into x. This n into n power 1 by n as n tends to infinity. I haven't still used this information. Now you see this, I simply cancel out. This one as n tends to infinity, 1 by infinity tends to 0. So we have 1 times x in the numerator. This is 1, as I said. This is what is a boxed atom here. So it's just 1. So my limit of un as n, even power 1 by n as n tends to infinity, as prescribed by Cauchy's and through test, turns out to be just x. Therefore, if x is less than 1, given series converges. That's the inference. Else, yeah. And if x greater than 1, given series diverges. That's it. So let's do a quick second example as well to cement the idea. Example 2. Let's look at summation un, which is given as a series 1 cube by 3 plus 2 cube by 3 square plus 3 cube by, what should have, 3 cube plus 4 cube by 3 power 4 and so on. So yeah, sometimes one also may give this because we know that this guy turns out to be 1. Sometimes it may be also expressed as 1 cube by 3 plus 2 cube by 3 square plus 1 plus 4 cube by 3 power 4. So I'm rewriting this because even if it is expressed in this way, you should still quickly recognize that this is of this format, and therefore your general term un is simply, see, everywhere it is n cube kind of a thing. 1 cube, 2 cube, 3 cube. And here it is 3 power n, I guess. Yeah, it is n. For first term 1, second term 2, third term 3, and so on. So 3 power n. So this is your un. So what does Cauchy's test prescribe? Look at un power 1 by n. That is n cube by 3 power n power 1 by n. And take its limit. So this turns out to be 3 by n, n to the power 3 by n, by 3 to the power n by n. Simply n to the power 3 by n by 3. right? So the limit that Cauchy's test prescribes is un power 1 by n. This limit, apply it to the expression that we just got, n power 3 by n upon 3 as n tends to infinity. So see, when n, yeah, I think we just use the same, this bracketed thing, n power by n tends to 1. We are going to use that. You see how we use it? So you see, this can be written as, I'll better write it here, n power 1 by n the whole cube, right? By 3 as n tends to infinity, right? So n power 3 by n could as well be written as n power 1 by n the whole power 3. And this, as I said, that this limit turns out to be 1. It is just 1 cube by 3, so 1 by 3. Therefore, un nth root limit as n tends to infinity is simply 1 by 3, which is less than 1. Hence, by Cauchy's test, we declare given series converges. Yes, so I end this class with this short exposition. Thank you.